Yes, ma'am.
Okay. Okay. Then we will start. So, last class, what we did? Did you remember?
We are discussing about NGET.
Okay, and get it was completed, right?
Yes, ma'am. Yes, ma'am.
Okay. So, how many types of gates? Can you tell me
It's
how many types of gates?
mainly it's mainly, ma'am, three types of GET.
Okay, basically there are three types of gates. Then one is the basic gates, second is the universal gate, third one is the special gates. Okay, under the basic gates we have AND gate, OR gate, and NOT gate. And under the universal gate we have NAND and NOR. And special gates are also there, so we will discuss it one by one. Let me open the. I'm sharing my screen. Can you see it?
No, ma'am.
No.
Yes, ma'am.
Yes. Okay. I think now you can see it. So, all of you, what is gate? It is clear. Why we are, what is mean by gate, then what is mean by signal. I think all these concepts are clear. Okay. Then we will move. First, we just give a brief discussion on AND gate, which we discussed on earlier class. Next, we will move to the OR gate, then NOT gate. So, for the AND gate, what is the symbol? What is the symbol for the OR gate? Wait. So basically, this is the symbol. This is the symbol for AND gate. Okay, and since we are having here, this is the input signal and this one is the output signal. A and B are the input signal, and Y, which is equal to A into B, is the output signal. Here basically we were using two input signal, so our possibility of truth table will be 4. Okay, so what is the use of uh, the truth table? Can you tell me? Okay, I will tell you then. See, in the earlier class, we said about what is logic gates and why we use gates. Gates in simple English, I just explain you that gate is nothing but like a gatekeeper on your college, on your on any institution, in your home, at your society. It is like the gatekeeper, and we are giving some rules to the gatekeeper that these are the rules. A person which have this quality, you can enter him into our home, into at your college, at our society. So basically here gates is like a digital circuit. Okay, gates is like a digital circuit, and our digital signal are the person which want to enter into our house, like our gate. Okay, so now the question is, how you give him the authorize, how you allow him to enter into your house. There must be some rules, and the rules is that is your truth table. Okay, rules is that is your truth table. If you have, suppose we have two input A and B. Okay, first, if you have 0, if you have 0, means what? No signal is there in the digital circuit. Means there is no signal in the digital circuit. And if we have signal in the digital circuit. Clear? Clear, or any doubt up to here? Okay, clear. Okay, I think you are clear. So in the AND gate, I'll minimize this one. So in the AND gate, we have 4 combinations. One is first one is the your 0 0, then 0 1, then 1 0, and 1 1. These are the binary input. Okay, so the sequence should be like this only. You have to memorize, or you have to just keep in your mind that the input of the sequence should be like this only. Okay, so we are having here an AND gate, and we have this symbol. The symbol of our AND gate is the symbol, or the representation of AND gate is this one. Okay, this one means this is a digital circuit which has its transistor, which has its capacitor in this circuit. But we are not drawing all this transistor and capacitor and all that. Likewise, we just denote it like this way. Okay, by this symbol. So this is our truth table, and if we have input 0 and 0, 0 means what? No signal. And beam, if we have through B also, we don't have any signal. So in our output will be 0, because 0 into 0 is equal 0. And if we have in first A, if we have 0, and in second if we have 1, suppose here if we have 0, and here if we have 1, so output will be 0 into 1 is 0. Anything the combination of 0 will be anything with multiplication of 0 will be 0. Okay, so this is all about your AND gate. Now come to the OR gate. Similarly, this is OR gate, and what is the representation of OR gate? Means what is the symbol of OR gate? So this is the symbol of OR gate. This gate you have to memorize. Means on gate, if you are asked to draw the AND gate, then that symbol you have to draw. If you are asked to draw the OR gate, then this symbol you have to draw. Symbol you have to memorize. Okay, this is the symbol for OR gate. OR means the addition. Addition means what? If in your question paper, if 2 questions come, and if within that 2 question OR is given, you are asked to write whether it is or that. Means what? Any one you can write, not both. Okay, like this way, A plus B means OR gate. And what is the truth table of the OR gate? What is the truth table of the OR gate? This one. See, the input will be same. The sequence of input, the sequence of this bits will be same, but the output will be different. What is the difference in the output? 0 plus 0 it is 0, 0 plus 1 it is 1, and 1 plus 0 it is 1, and 1 plus 1 in binary, in digital form it is also 1. Okay, now means I'm just going to explain you in simple language. Suppose in our college we have security person. There are security person in our gate. Okay, so uh, suppose you have uh, your college I card and you are in uniform. Okay, two rules we have given to you: whether you have your I card or you have to wear your uniform. Okay, now in first case you don't have any I card or you haven't wear any your college dress, you are not allowed to enter in the college. Okay, that means what? 0 plus 0, that is 0, means either this or that. Between two you have to follow one rule. Either either with you have your I card or either you have to wear your uniform. Like this way, you don't have any I card but you wear your class uniform, college uniform, so that's why you are allowed to enter the college. So in the third case also, in the fourth case, you have your I card and you also and you wear also college uniform. Means what? Definitely you are allowed to enter college. You can simply relate like this way also. Or means what? Either this or that. And means what? Both. You have to do both. There is no choice. But here you have choice. So this one is a representation of or, means what I can say. Wait. This one is the logical or the diagrammatic representation of OR gate, and A and B are the input and Y is the output. Clear OR gate? Yes, clear. Okay, thank you. Then we will proceed to the NOT gate. Now, what is NOT gate? NOT gate means what? It is the inverter form, or you can say it is the converter form. Means what? When you give a logical input of 0, the answer will be 1. Opposite. When you give an input of 1, the answer will be 0. Means inversion of input, logical inversion of input. The output of NOT gate is the logical inversion of input. Whatever output you give, that the output will be the inversion of your input. Like if you give 0, then the output will be 1. If you give 1, the output will be 0. Now let's see what's the diagram. So this is the diagram for gate. Like this way, you have to memorize these gates, means the symbol of this gate. There is no other option. You have to memorize the symbol of gate. Okay, it is not showing here. Okay, why it is not showing in the screen? Okay, now it is showing. Okay, so NOT gate is the conversion, or you can say complement of input, conversion of input, inversion. These are the things then you can add. So basically here in case of NOT gate, since we have only one input signal A, since we have only one input signal A, that's why we have two possibility, either 0 or 1, whether the input will be 0 or whether the input will be 1. If the input will be if the input is 0, the output will be 1, and if the input is 1, the output will be 0. I think NOT gate is also clear. Up to here clear. Basic case it is clear. And or not, you can skip me a chat. Reply me in chat. Yes, it's easy. Your day-to-day example, day-to-day life example, then it will be very easy. And if you just no, ma'am, it's not clear. Who is T? Your roll number is 004. It's not clear. I tried to explain you in a very simple way. Which portion is not clear? And it's also not clear. Which portion you have doubt? Which portion you have doubt? So tell me, if you have any doubt, tell me so that I can proceed it to our further. This is AND and not get NAND get. Sorry, NAND and NOR get. MK and T. You write here it is not clear to you. Which portion you have doubt? No doubt. Okay, then fine. So let's move to our next, that is universal gate. Okay, why it is universal gate? Because we can implement or we can make any boolean function through this gate. Okay, means through this, why it is universal? Because from this gate we can make any gate. Okay, we can make any gate from this NAND and NOR gate. So that's why it is known as the universal gate, because from this, in universal gate, two gates are there. One is NAND gate, another one is NOR gate. So these NAND and NOR gates are called universal gate, and we can implement any boolean function which is in sum of product form by using this AND gate. Sum of product form, or any product, or product of sum. If we want to make this sum of product form, then we can use by using the NAND gate. And if we want to make the product of sum form, then we can make it by using NOR gate. Don't be confused. We will be doing this by taking an example. Okay, so don't be confused with my language. So basically, what is AND gate? AND gate is that gate from which we can make any gates. That's why it is known as universal gate. Clear? Okay. now. Okay, now I am going to share you something. Can you see something? Hello?
Yes, ma'am.
Can you see something? This one not. I have logged in with two device from two device. One is from my laptop and another is from my phone. This laptop is not that word file is not. I'm not talking about that word file. One camera is there. Have you? Now you can see the camera.
No, ma'am.
A pen and paper that I'm going to write.
No, ma'am.
I'm using a pen and paper. No.
Yes, ma'am.
I think you can see, right?
Ma'am.
One page paper. Yes. Now you can see it. Now you can see it. I will minimize. Now you can see it. No? Hello. Hello. Now you can see.
Yes, ma'am.
Okay. So here we are basically talking about our universal gate. One is your NAND gate and another is the OR gate. So we will be talking about first NAND gate. Okay, NAND gate. So NAND gate means what? Not after N. Not after E and D means AND gate. After AND gate we have to use NOT. Okay, after AND gate first we have to use AND gate and after AND gate we have to use NOT gate. Okay, in the basics gate we have discussed three gates. One is AND gate, one another is OR gate and another is NOT gate. So in NAND gate first we have to use AND gate and after that we have to use NOT gate. Clear? So what is the symbol of AND gate? What is the symbol of AND gate? What is the symbol of AND gate? If you have remember, this is the symbol of AND gate. Okay, this is the symbol of AND gate. Okay, so after that what we have to use? NOT gate. So this is the symbol for NOT gate. Okay, this is the symbol for AND gate and this is the symbol for NOT gate. And suppose we have A and B input and our here output, suppose we assume it as Y dash. Okay, and after passing it to the NOT gate, our input is Y. Okay. So in short, we can write this gate. We can write this gate as, see, this is NAND gate. This portion is the NAND gate, and just similarly we will add the back portion of NOT gate, means the circle one. So this will be your NAND gate. Here input A and B and our output is Y. So this is the representation of NAND gate. This is the, you can say, diagram of NAND gate. It is clear. Diagram of NAND gate, it is clear.
Yes, ma'am.
Clear? So now we will move to the truth table. Okay, truth table. So in truth table, A and B we have input. Okay, A and B we have input. And A dash, here Y dash, and here Y. So move to our NAND gate 0 0 1 1 0 1 0 1. Okay, this is our so first in AND gate, if we have input of 0 and 0, what will be the output? If we have input of 0 and 0, what will be the output? 0 into 0, our output will be 0. 0 into 0 into 1, output will be 0. And 1 into 0, our output will be 0. And 1 into 1, our output will be 1. Up to here, it is AND gate. Okay, we are just writing here the truth table of AND gate. Okay, in the diagram also, up to here it is AND gate, right? If we have A and B input and the output is Y dash, means up to here it is AND gate. But when this one flows through the NOT gate, what will be the result? Here means what? So NOT gate, if we give 0 as an input, the output will be 1, because it is NOT gate. This is the inverter form of output. So here, if the input is 0, the output will be 1. Okay. If the input is 0, the output will be 1. And if the input